proven engineers of repute that have done well for themselves, and they come here to educate young people, make them interested in engineering, because like I always say on this show, so goes the engineer, so goes society. If Nigeria is going to move from where it is to where it should be, then the engineering profession must be there and be top-notch. My name is Tunde Olanyero, and it's a very interactive one. We get to talk to you. You also get to talk to us, because it's going to be, it's sponsored by President Shilon, I must say. Is the reason why we are here, the reason why we come to your viewing pleasure every Friday. And the program is interactive, so the question for today that you are to answer is a mathematical question. In a right angle triangle, AB, AC, BC are 3, 5, and X. If BC is, find BC and name the theory that that is used to find BC. You can see this on your screen. If you know the answer, please call us. Now, don't give us just one answer. Don't give us BC. Give us the theory that the theory of that you use to solve the problem. Then you get the prize. The prize is courtesy of our sponsor, Prince Engineer Shilon, FNSC. My guest is already in the house. Without wasting any of our time, we'll take this very short break. When we return, I will introduce him to you, and I'll tell you what topic he's going to be discussing with us today. I'm glad to know that you are still there, and my guest for today is Engineer Dr. Olonade Kolawole Adisa, FNSC, and he's going to be talking to us about a very interesting topic, equilibrium of forces in practice. Equilibrium is a subject in physics for those of you that are science students, especially in the O-level secondary schools, the subject in physics, and what is the practice? How is it applicable? That is what Engineer Kolawole Adisa is going to be talking to us about today. You're welcome to Engineering, sir.
So thank you so much for this opportunity to address our student once again. Yes, like the presenter adroitly mentioned, in the next few minutes, I'll be talking to you, the students, about the equilibrium of forces. Right from SS1, SS2, even up to SS3, you will have been taught about moments. That is equilibrium of forces. And I will just give you the background of what this equilibrium of forces is all about in a very simple way to understand. And then I will also let you know how to apply this in the real life, especially in engineering, so that by the time you are learning these courses or subjects or this topic in your school, this idea, the practice of it will always be in you, and then it will give you opportunity to be looking forward to see when you are going to have opportunity of this in practice, if you are fascinated enough to make sure to study engineering. So if you look at this slide, you will see one of the prominent footballers who is about to head a football. You will see in that particular picture, or in that particular slide, you will agree with me that the ball there is not in equilibrium. So also Osima is also in equilibrium, it's also not in equilibrium. If you look at this building, this was not how this building was before. Something happened to this building, it moved and it fell, and everything, it collapsed. So then, what exactly is really causing all of this? It is all about force. So in your elementary subject in physics, we will say what is a force. A force is just about push or pull. When you push, then you are applying force. When you pull, you are applying force. There could also be different types of forces. As you know, you can have a contact force, you can have force that does not really have any contact. But when there is force, when there is evidence of force, what effect does force have on a body? When we say body in physics, it means just anything. It can be building, it can be vehicle, it can be human being, it can be table or anything. If you look at this particular ball, this ball is in a stationary state. It's in a stationary state, but when there is force, what happens to the ball moves. That is why if you see anything that is moving, there is force that is really changing it. Another second effect of force is about deformation. If you look at that ball, that piece of bread, if you put it on the weight, you will get the weight or the mass of that bread. But if you look at what happened when you apply force, you will see there is a compression there because a force has been applied, but the weight of the force, the weight of the ball, the bread has not changed. The mass has not changed. But the volume has changed because there is compression. So this is part of the effect that you have from force. So now when you talk about force, then we want to talk about equilibrium of forces now. If you see this particular figure, you will see Shola and Kule. They are doing seesaw, one on the other side, the other on the other side. You will see everything is stable. No one is bending from the other because the weight of Shola and the weight of Kule, when you add them together, is the same with the weight of the fulcrum, that is the hinge that is holding them. What do you think will happen if the weight of Shola is more than the weight of Kule? You will see that there won't be any equilibrium. Therefore, the first law of equilibrium is total upward forces equal the total downward forces. In that case, you will say summation vertical force is equal to force, is equal to 0. In the second case, when you see there is a pulling, father is pulling to the left, then the son is pulling to the right, you will see that the force of the pulling of the force applied by your father is about 150 Newton, and the other one is about 85 Newton. If I ask you where do you think the movement will go, definitely it will go towards father. Then what happens if the son also applied the same force as the father? Nothing will happen. It means Jasmine, who is on that trolley, will not be moving. Therefore, the total forces on the right equals the total forces on the left. We give you an state of equilibrium. That is another equation of equilibrium saying total horizontal forces equals 0. Then the last law of equilibrium is about moment. Moment is all about turning. When you apply force, there will be turning. If you want to open your door, you apply force, then the door will turn at the hinge. This turning can be clockwise, it can be anti-clockwise. Turning is also having effect. So for anybody now, when you say body, I'm talking about objects, when they are in equilibrium, it means all the total forces, total clockwise moment, and total anti-clockwise moment will be 0. It will be equal, which is also giving you another equation we call summation of moment. Total moment is equal to 0 in a body for the body to be in equilibrium. You can see that there are 3 equations here. Summation V equals 0, summation H equals 0, summation M equals 0. When you have a problem to solve, if forces, total unknown forces is equal or less than 3, then you will use this approach to solve the problem. You will use this approach to be able to understand, to be able to resolve the problem. If one force is given, the other one is not given, you can do it. So in that case, we will say such structure is a determinate one. But when the number of unknowns are more than 3, then you have indeterminate structure. By that time, you will not be able to learn that while in secondary school. But when you get to university, you will see where you have many unknown forces that you want to determine using the principle of equilibrium of forces. How do we now apply this equilibrium of forces in real life? We have been seeing a lot of bridges. Vehicles are moving down there. Vehicles are loads that is on bridge. Then we have the piers that is supporting this bridge. If the total forces of the vehicle equals the total forces from the pillars or from the piers, then the bridge will be in equilibrium. The same thing in the building here. You will see the building with pillars, with beams, with slabs, all of them. Even when it is completed, human beings are also there exerting load applying load on the building. If the soil that is supporting the wall of this building is not having adequate force to resist, what will happen is that the building will sink, and then the building will also collapse. And you will see, if you hear anything about failure in structures, you will always realize that it is either that one force is exceeded or the other. Then another major area of structures that we do in engineering is design of reservoirs. The design of the reservoirs is, reservoir where we have a lot of water. When you have a lot of water on it, and then this water is being supported by pillars, when the load of the water and the reservoir is also the same with the pillars, then the structure will be stable. And then the last but not the least, which is a very common one, is maybe you have not seen a dam before. There is a huge forces, we call it hydraulic forces, that is coming from water. And because you need to impound water for use, either for irrigation, either for swimming, either for fishing, then you need to support the weight of the water. So these are places where you will see where equilibrium of forces are applied. Mainly the civil engineers, the structural engineers, they make use of this equilibrium of forces to design all the things you see today that are civil infrastructure. They are always about equilibrium of forces. You apply force, then you make sure that no one is exceeded. So in conclusion, my dear students, I want to conclude by trying to relate the relationship between scientists and engineers. Scientists dreams about doing great things. They propound a lot of theories, but the engineers do them. Engineers now apply this theory into things that you will see. When you talk about the Archimedes principle, that was a scientific principle, but engineers use this scientific principle to build ships that you use on the river. So in conclusion, we say when people are busy enjoying life, engineers are busy making life enjoyable. If you want to be part of those people that will make life enjoyable for people, kindly take engineering as a course for study. Thank you, my dear students.
Thank you very much. And I want to say a big thank you to Engineer Olonade for doing justice to this topic. It's as though you are taking us back to school. Back to school. But I wanted to ask a question, but you have actually spoken about it. I wanted to ask that what arm of engineering apply these principle, but you've spoken about it. Yes. Is it only limited to structural engineers and...
No, it's not limited to structural engineers. Nearly all engineering fields use equilibrium of forces. Even the mechanical engineers, the automotive engineers, when they are putting all things together, maybe they want to talk about the crankshaft, they want to talk about the tire too, because tire is also exerting force on the road, or the wheels that is moving. You want to make sure that at least the load is not too much for it. Either you test the material, because when you apply force on material on a body, stress is developed internally. When the stress developed internally is more than, or the force applied is more than the amount of stress that the material can cope with, what will happen is that material will fail, and then any eventuality can come after that.
Now, how important is the study of physics and maybe probably mathematics to being an engineer? Because we observed that most young people, one, don't like mathematics. Number two, the next subject to it that they don't like is physics.
Yes, there is no way the background for any engineering course is physics and mathematics. Because most of the principles used in physics are what we try as much as possible to put into practice in physics, in engineering. And then because when you have understanding of anything, you want to really show that this is how it works. You bring everything back to figures. And when you bring everything back
we have a caller. Hello. Hello, good evening.
So when you bring everything back to figure, okay, then in that case we are talking about mathematics. So mathematics and physics, they are two major courses, subjects that you really need to...
Okay, follow on, Sean. Can you hear us? Hello, can you hear us? I think we lost. I think we lost it. Please call us back. We will seriously like to hear from you. How then can young people know this subject? Because I was with a young person and we're talking about moments, clockwise and anti-clockwise, and it was like, this looks like jargon to the young man. What mindset should they bring? Hello, Glory from where? Hello, Glory. How are you doing, Glory? How is Moe today? All right, please go ahead. You have to ask my guest a question before you answer my question, so go ahead. All right, okay, go ahead and answer my question now. You will answer your question very soon. What is your theory? You can't just give me that answer. What theory? No, there's a name. There's a name I'm looking for, Glory. There's a name I'm looking for. In a right angle triangle, if you want to solve it, there's a name I'm looking for. The name of the theory. All right. Hang on. I will let you know if you are correct or not. Thank you very much. All right. Okay, he wants to know why you said.
Yes. In fact, what we discussed this evening is an indication that physics is a background to most of the engineering courses. We talk about equilibrium of forces. You will see where the forces is coming from. You will see that if you agree with me, you will know that design of building, design of bridges, design of dams, they are engineering duties. And in the engineering duties, you need to understand the equilibrium of forces. When you are talking about forces, you are having the forces in figures, in numbers. And there are a lot of equations, interrelationship, functions that you have to put together, and then you solve some problems. And then when you are doing that, you're also doing mathematics, because mathematics is just about the relationship between figures.
All right, I think we have another caller. Hello, good evening.
Good evening.
Good evening. How are you doing?
I'm fine. How to answer the question?
Okay, go ahead.
The answer to the question is 4.
Okay, and what's the theory?
And the theorem is Pythagoras theorem.
All right, but you hold on. You have to ask my guest a question before you go. So,
How to answer what mathematics so important to what is Latin?
is okay? You answer a question. I want to know why mathematics.
So why mathematics? Mathematics is, for instance, if I tell you that, if I tell you that you are pushing a table, and this table will resist, this table requires quantity certain, it has a weight, and then I ask you, if I want to push this table away from here, what do you think will be the amount of force that I need to exert on this table to move it? That simple statement, you can convert them into figure, and then from there, you resolve it. What we do in engineering is that any problem that exists, just like in your mathematics, they will have what you call word problems. There are problems that is stated, and then for people to understand these problems, they convert them into numbers. For instance, if I tell you, if you say that somebody give you orange, and then you are taking half of it, your brother is taking 50% of your own, what will be the remaining one? You need to do it, you convert them into figure, then you'll be able to determine what will be. 50% of your own is 1/4, and your own is 1/2. You add 1/2 to 1/4, that will give you 3/4. Then you subtract it from the one orange, then it means you have 1/4 remaining. If you don't convert them into figure, into numbers, and establish a relationship to solve such problem. So this is why we engineers always talks in figures, always resolve things in figures, because that's the best, that is the only way you can show people that what you are doing is not magic. That is it.
All right, I would like to ask you, what attitude should a student bring to the study of, the two callers spoke about mathematics and physics. What attitude should they bring to class to be able to understand this thing and know that it's not rocket science?
Yes, actually, I want to advise students. I was once a teacher in secondary school. I always tell my students that mathematics is the cheapest subject to learn because it has formula and it has rules. Once you understand the rules, you just apply the rules. And then also physics is also very simple because there always will be a relationship. There are formula. Once you can understand this formula, then you'll be able to resolve a lot of questions in physics. I would then advise our teachers who are taking this subject. They should not make the subject so much difficult, and they should always relate this subject to things that these students used to do in their respective home for them to appreciate. When they appreciate the subject, and then they will fall in love for it, and then they will be able to do it. And it all depends about how the teachers teaches these subjects. If not, you know, generally, if a student hates a particular teacher, he will hate that subject. So that is why our teachers who are teaching physics, who are teaching mathematics, they must find a way of making their students so much beloved to them, and then they love them, then they will love the subject.
Right. In less than, maybe in 30 seconds, just encourage young person that is watching this, that wants to be an engineer. Word of encouragement.
Yes, I will, like I did a quotation there, engineers solve all the problems. Don't think about what you find in all your environment today. You will see that almost everything is a product of engineering. So if you are able to do that, then you always feel proud that you are making a world comfortable for people to live. Even in medical sciences, everything is all about engineering. Without all the biomedical engineering, all the gadgets, all the equipment developed by engineers, what will the medical doctor do in their area? I'm not saying that the medical doctors are also not contributing. They are also doing a lot of sciences too. But engineers is also the mother of all this because they make life enjoyable to people.
All right, engineers make life enjoyable to people, and on this note, we'd like to say a big thank you to Engineer Dr. Olonade Kolawole Fnse. Thank you so much for
thank you for the opportunity.
For coming, and thank you for the exposition, really. And also thank you for watching. Today, the question for today, the answer is 4, and the theory is Pythagoras theorem. Pythagoras theorem. So Folorunso from Abule Tokuri, right? You got it correctly. For today, this week, so we are going to be looking at that question on the screen. Mechatronics is an arm of transport engineering. True or false? Note all our social media platforms and drop your answers. If you get it correctly, you surely get a prize from our sponsor, Prince Engineer Yemisi Shilon, FNSC. So that's our question for the week. So, Folorunso, I would like to give you this number. Call this number and get your prize for your answer, for your question, 0703-161-1497. 0703-161-1497. Thank you so much, and thank you to our sponsor, Prince Engineer Yemisi Shilon, FNSC, for sponsoring this program and for making it come to your viewing screen every Friday by this time. My name is Tunde Olaniran, and until next week, bye-bye.